Okay, this is the 12.5 part 2. This is the second video for that. So on the back of the last page, which we gave you an overview of the second derivative test, we have some examples that we can do together. They are similar to your homework questions, so hopefully that will help you. We're gonna need to find the absolute maximum and minimum if either exists for each function. Okay, so let's look at number 28 here. We're going to have a function equal to x squared plus 4x minus 3. And because they're doing the second derivative test, so you're going to need to find both first and second derivative, right? And we know this graph because the highest power is what? X squared. So it's an even leading power, right? So for even leading power, A is positive. What do you think the end behavior should be? So it's just a regular open up parabola, right? What is the maximum turn? The maximum turn is going to be degree subtract 1, right? So degrees 2 minus 1 equal to 1. So it should have a absolute minimum but not maximum, right? So no absolute maximum because it keeps going on forever, but it should have an absolute minimum at the critical value, right? Or critical number. Okay, so if we know we need those information, we're going to need to take the first and second derivative, right? We know domain for this particular graph is negative infinitive to positive infinitive. And then we found the f prime of x. So hopefully by now you're pretty good with the basic rule. This would be 2x plus 4. That's my first derivative. And if I set that equal to 0, then I can find my critical value or critical number, right? Set the first derivative equal to 0. All right, and solve for x. So we got 2x plus 4 equal to 0. 2x equal to negative 4. And then x equal to negative 2. Are we okay? So that's my critical value. So if I want to find that particular point, to find the y values, where should I plug it in? So that's usually a common mistake for students. We should plug it back to the original function from negative 2 to find that y value, right? So that would be negative 2 squared plus 4 times negative 2 minus 3. So that would be 4 minus 8 minus 3. Negative 4, negative 3 is negative 7. So my critical point is negative 2, negative 7, right? If we understand the graph, we already know that is my absolute minimum, right? But we're going to do the second derivative test, so let's double check. So the second derivative test, found the second derivative. We have just 2, right? Because it's 2x plus 4, so it's just 2 here, which equal to positive. When you have a second derivative, which is positive, means concave up, like a smiley face, right? Positive. So because of that, then it's going to have the minimum. Here is absolute minimum point, which we already found x and y value, right? Negative 2 and negative 7. Again, we have no absolute maximum, right? And it depends on how your homework want you to write it. This is the point, or you can say absolute minimum value equal to -7 at x equal to -2, or you can put it in the form of f of x equal to y. Then it would be f of what? -2 is my x equal to my y is -7. So I don't remember how your book write it, but these are all the options you can have. So this is one of the example. Let me see if I can zoom out. Sorry about that. Okay, I think that's the maximum I can do. All right, so let's look at the second question that we have there. So the second one is number 32, which have f of x equal to -x cubed minus 2x plus 4. So this time, let's think about the end behavior. This is what kind of leading power? So this is odd leading power. If A is negative, so this kind of graph have what kind of end behavior? So hopefully you know it's going to be left side up, right side down. What is the maximum turn? So maximum turn is the degree 3 subtracting 1, which should be 2, right? So if you sketch the graph, it should look like that. So just looking at this, hopefully you understand, because the domain is going on forever both sides, right? Negative infinity, positive infinity, and they want to know the absolute max and absolute minimum. And because I don't have the lowest point and the highest point, so the answer should be no absolute max, no absolute minimum. You have relative or local minimum, relative and local maximum only. So if we do the derivative test, how does it look like? If you do f line of x, that would be -3 x to the second minus 2, right? And the critical number would be setting f line of x equal to 0. So if we do that, I'm sorry about that. It's kind of too close, I think. This thing. Sorry. Let's see. Okay, maybe better. Alright, so let's see. Set that equal to 0, -3x squared minus 2 equal to 0, -3x squared equal to 2. Divide both sides by -3. So we got x squared equal to -2/3, and you have to take square root, right? So take square root both sides. And you have x squared -2/3. So your problem is you're going to end up with I, right? You're supposed to need to rationalize this too. But this is not real number, this is imaginary. So for all real numbers, there is no critical values. So that's why we don't have the absolute maximum. And if you understand the end behavior in the graph, that also suggests you don't have absolute maximum and minimum. Okay, let's try the next question. Let's see. The next question is number 34. Okay. We are still trying to find the absolute maximum and minimum, right? So let's see. 34 say f of x equal to x to the 4 minus 4x cubed. So how does that work? If we think about the end behavior, this is what kind of leading power? 4 is even leading power, with A is positive. The maximum turn will be the degree 4 minus 1 equal to 3, right? So even leading power, A positive, we talk about it, it's supposed to be both sides up. With maximum turn is 3, so 1, 2, 3, look like a W, right? It looked like there is no absolute max, right? Because they go on forever up. So no absolute max. And we may have some absolute minimum point. All right. Maybe 2, up to 2. So let's find the first derivative. So f prime of x, that is 4x to the third minus 4 times 3 is 12. X go 1 degree lower, right? 2. So that's my first derivative. And then we need to set that equal to 0 for the critical number, right? Okay, maybe more than 1 this time. So we got 4x cubed minus 12x squared equal to 0. How do we solve for x? So hopefully you know we should factor. So both of them can be divided by 4. Both of them have x squared. So after we put that out, we still have x minus 3. All right. So we set each of them equal to 0. 4x squared equal to 0. X minus 3 equal to 0. X equal to 3. Divide both sides by 4. X squared equal to 0. So x basically equal to 0, right? All right, so we have 2 critical numbers. If I need to find the y value, we need to do what? Plug in where? F of x, so f of 0, f of 3. So f of 0, we need to go back to the original function. We have 0 to the 4th power minus 4 times 0 to the 3rd power. And then 3 to the 4th power minus 4 times 3 to the 3rd power. So the first one is just 0. Second one is negative 27, is that right? I think it is. Okay. So the points, the critical points is going to be 0, 0, and the other one is 3, negative 27. All right, and then we're going to need to see its concave up and down, so we do f double prime of x, find the second derivative, starting from this guy. Take the derivative would be 4 times 3 is 12, x to the second, minus 12 times 2 is 24, x to the first power. So that's my second derivative, sorry. And then I need to set test f double prime of z, right? Which is those 2 critical number, x equal to 0 and x equal to 3, right? So I need to plug in f double prime of those 2 numbers. We have 0 and 3. So equal to 12 times something square minus 24 times something. And we plug in 0 here, which is just 0. We have plug in 3 here. And take a minute and see if you can find that number. Hopefully you get 36. All right, so the top one is 0, mean the test failed. So inconclusive, right? And then the second one, we have 36, which is a positive number. Positive number means positive person. You have a concave up. So if you have a concave up, then it means this is an absolute minimum. Okay, so your absolute minimum is going to be at the point 3, negative 27, or you can say f of 3 equal to negative 27, or absolute minimum values is is negative 27, that's the minimum value at x equal to 3. So they all mean the same thing. But to approach these kind of problems, I would suggest think about the end behavior in the graph and figure out if it actually have absolute maximum or minimum. And then after that, we are going to try to do the first and second derivative tests and find the actual number. All right, thank you.